You know, a story from way back in 1965 might just be the perfect way to understand the AI of today. It's a wild one involving a top secret mission, a major rules violation, and a sandwich. Yeah, a sandwich. Okay, let's get into it. So picture this, March 23rd, 1965. Astronaut Gus Grissom is piloting the very first manned Gemini mission, and his co-pilot, John Young, decided to smuggle some contraband on board. What was it? A corned beef sandwich. And when they took a bite in zero gravity, crumbs went everywhere. Now, this wasn't just messy. Those floating crumbs could get into the electronics, or worse, into an astronaut's eye. It was a real flight safety risk. A small, seemingly harmless act with totally unexpected, systemic consequences. And that brings us right to today. Because obviously we're not actually here to talk about NASA's Gemini program. We're here to talk about Google's brand new AI model, which, you guessed it, is also named Gemini. So why the story? Well, it perfectly illustrates a core idea. In a really complex system, a tiny input can have massive, unpredictable effects. With Google's Gemini 3, those effects aren't crumbs in a cockpit. They're breakthroughs that are setting a whole new standard for what AI can actually do. All right, so let's get into the hard data. How do we really know that Gemini 3 is as powerful as Google says it is? Well, it all comes down to performance benchmarks. You can think of them as the Olympics for AI. And right now, Gemini 3 isn't just competing, it's setting a new state of the art. It's taking home the gold. Let's see how. Just look at that number, 91.9%. That is Gemini 3's score on a benchmark called GPQA Diamond. And this is not your average pop quiz. We're talking graduate-level questions from fields like physics and biology, specifically picked because even human experts, people with PhDs, often get them wrong. So scoring almost 92% isn't just good, it's a display of expert-level reasoning that puts this model in a completely different league. Now check this out, because this is one of the biggest leaps. This chart shows us performance on a test of abstract visual reasoning. Basically, it's testing the AI's ability to look at a simple visual pattern and figure out the rule behind it, kind of like a visual IQ test. And for years, this has been a huge, huge stumbling block for AI. I mean, you can see the older models barely even scored. But look at that jump for Gemini 3. Going from under 5% to over 31%, that's not a small step. It's a sign of a fundamental new ability in nonverbal problem solving. And this top-tier performance isn't just in one little area. This table gives you a head-to-head comparison across a bunch of different skills. You've got MMU Pro, which tests how well it understands text and images together. You've got Terminal Bench, which sees if it can actually act like a programmer and write code. And then Vending Bench, which simulates really complex long-term planning. And what do you see? In every single category, Gemini 3 Pro is taking a consistent lead. The big takeaway here is that this isn't a one-trick pony. It's a true all-rounder, and it's pushing the state-of-the-art forward across the board. Okay, so we've seen what it can do. But for all the developers and builders out there, the real magic is in how you can now use it. Google has rolled out some incredibly powerful new tools under the hood in the Gemini 3 API that could seriously change how we all build AI applications. Let's take a look. First up is this new concept called thought signatures. Honestly, the easiest way to think about this is like the model's encrypted work-in-progress notes. Every single time it reasons through a step, it generates one of these signatures. And what this does is allow it to remember its train of thought, not just for one response, but across an entire conversation. It's like having a memory. And here's why that is an absolute game changer. Just look at this multi-step task. First, you ask it to check a flight. The model goes and does that, but it also returns a thought signature. Then you send back the flight info, but you include that signature with it. And now the model has the full context of its previous thought process, which lets it seamlessly move to the next logical step, booking a taxi for your arrival. This is how AI stops giving single-shot answers and starts completing complex, real-world workflows. And for any developers moving over from older versions, Google has actually made things a lot simpler. The old way to control the model's reasoning was to set a thinking budget. It was precise, sure, but also kind of complex. The new way is just a simple thinking level. You just pick low or high. This gives you way more predictable performance without you having to dial in a specific number. It's a small change, but it makes building complex apps that much easier. Okay, so we have new performance benchmarks, we have new developer tools, but what does all of that actually mean for the real world? Well, this is where all the theory starts to get very tangible and very fast. We are seeing the rise of what are called agentic systems. This is AI that doesn't just answer your question, it performs a whole job.
It can autonomously code entire software features, navigating file systems, and running its own tests. It can act as a research assistant that doesn't just give you links, but actually reads them and synthesizes all the information into a neat report. And hey, remember that vending bench score we saw earlier? That test simulates an agent making complex plans over a long period of time. Gemini 3's massive lead there shows its superior ability to think ahead and actually execute on multi-step tasks.
And the impact in a field like healthcare is just profound. Gemini 3 is already being used to accelerate drug discovery by sifting through enormous genomic datasets. It can interpret really complex medical images, like 3D scans, to help doctors with diagnostics. And on a super practical level, it's already making a huge difference. In some hospitals in Japan, it has reduced the documentation workload for nurses by over 40%. That frees them up to focus on patient care. That's a real-world impact. So, this level of capability doesn't just create new products. It completely reshapes the entire industry and, it forces us all to ask some really important questions. So what does this all add up to? Well, we might be witnessing a major shift in the so-called AI race. For the first time in years, it's possible that OpenAI no longer has the undisputed top-performing model. With Gemini 3, Google has a very, very strong claim to the throne. And their secret weapon might just be their vertically integrated stack. That means they control everything from designing their own computer chips all the way up to the model itself. That gives them a powerful long-term advantage in both cost and efficiency. But of course, with this kind of unprecedented power, we also face some unprecedented challenges. This isn't just about who has the best model anymore. It's about how these models are built and how they're rolled out to the world. And look, the road here has not been perfectly smooth. As we've seen, these models are trained on vast data sets from the internet, and they can inherit and even amplify our human biases. The controversy over Gemini's image generation, where it created historically inaccurate pictures, led Google to pause that feature entirely. It really highlights a critical issue for the whole industry. Building AI that is both inclusive and factually accurate is incredibly, incredibly difficult. And at the end of the day, these tools are only as effective as the trust that we, the users, place in them. Which really leaves us with the biggest question of all. We are witnessing the creation of tools with capabilities that were literally science fiction just a few years ago. The performance is undeniable, the potential is immense. But as we start to integrate these systems into every part of our lives, from medicine to coding, we have to ask ourselves, how do we steer all this power? How do we make sure that the future we build with it is the one that we actually want?